Is the sound better now? Okay. Okay. All right. All right. Apologies for that. Thank you very much. All right. So my name is Oluwaseun. I'm from Nigeria, and of course, the United Kingdom is my second home. So the time difference is, I'm sure most of us are connecting from the US. And of course, it's 1 a.m. here already. It is 1:10 a.m. already, but of course, that's fine because this is the time where you can do a lot of work without any disturbance and interference. Right. So basically, I just want to introduce to us what we do before we go into the AWS console and start building out the architecture that we have. So basically, we run a DevOps training. It's a 5-month DevOps training program. And of course, you know, DevOps involves a lot of tools, right? If you want to become a DevOps engineer, there are a number of tools that you must be familiar with. You must understand, you know, a few things about agile methodology. You know, what's the difference between an agile methodology model and the soft, you know, the traditional waterfall model, right? So, and then as a DevOps engineer as well, you need to understand the duties and the role of a DevOps engineer. You know, what does a DevOps engineer do in the day-to-day? So basically, a DevOps engineer is somebody that, you know, is between the development and the operations team. So what you do mostly is that you are the one that will build out the architecture for, you know, the software, you know, that is being used in your organization. So the end-to-end infrastructure from when the code is being, you know, published as an artifact and then onto the production system, you build, you know, the entire pipeline and ensure that there's proper monitoring, and then the software, you know, development process, you know, goes on without any kind of hitch, right? And of course, as a DevOps engineer as well, you must also understand, you know, Linux operating system. Now, not as maybe a professional, but of course, majority of the systems you have in a production environment or in the work environment, quite a number of them run on the Linux operating system. And of course, you need to understand all of that as well. So in the course of the 5 months, you know, we look at, you know, these different topics, the Linux operating system, we look at version control, because you need to understand Git as well. And of course, you know, all these GitHub, GitLab, Bitbucket, and all of them, they are all built on top of the Git, you know, command line interface. And then we also look at package managers. We look at the Nexus repository where you can push your artifact. You know, we have image repository, and then we have artifact repository. So artifact repositories are repositories whereby, you know, after a software developer has developed his or her code, then you can package those code in terms, you know, in form of an artifact and then push it to an artifact repository. All right. And then you, as the DevOps engineer, you can take it from there and then package such artifact into an image, in this case, a Docker image, where you now deploy that into the production system. And then that can also be managed by a Kubernetes cluster. So in the course of the 5 months, we look at all these trainings, Docker container, CI/CD, Jenkins build automation. We look at AWS primarily. Of course, there are other cloud providers, but of course, AWS is broader, and there are a lot of services on AWS. And of course, it's the most popular, you know, infrastructure as a service, you know, cloud provider out there. And then we also look at Kubernetes, right? It's, of course, Kubernetes is, you know, everybody's talking about it these days. Most organizations, they are moving their workloads into the cloud, and most people are trying to do away as much as possible with, you know, server administration. So most people are deploying their applications in form of Docker containers, and then you have Kubernetes manage, you know, all of that Docker containers for you. And then after that, we then dive into EKS on AWS, Elastic Compute, Elastic Kubernetes Service, and then we look at infrastructure as code, Terraform. Today as well, in the course of the training, we're also going to be, you know, seeing Terraform at work. And of course, we're also going to be looking at CloudFormation. Now, what we have done in the demo of today is that the architecture that we have there, I'm going to be walking us through, you know, because for some of us, if you attend an interview, sometimes they give you, after the first phase of the interview, you know, you talk with a recruiter. After you've discussed with the recruiter, then you move on to the technical interview. Now, for most technical interview, they give you some kind of architecture some kind of problem that they want you to solve, and then you come back. What we're going to be looking at today is, if you are presented with this same architecture, how are you going to approach it? Now, let's say you've gone for an interview, you passed the first phase, and then the second phase, they give you this architecture that we have, that we shared just now. So how do you approach, such architecture? How do you build it in your own environment? For the most part, most organizations, they would prefer that, the VPC section particularly, they'll prefer that you build it out using infrastructure as code. Now, they won't tell you whether to use Terraform or CloudFormation, but they just want to see how you're going to build out the VPC. If you're going to build it, just going to the console and clicking and building it out, or you're going to deploy an infrastructure as code tool like Terraform or CloudFormation to build it out. So for the architecture of today, what we have done is that we have two templates that we've created. So we have one for Terraform, and then we have one for CloudFormation. So basically, I'm going to be walking us through how, the difference between this Terraform and then the CloudFormation. What is really the difference between them? So basically, Terraform is just is a tool that is cloud agnostic, so which means it works basically with every cloud provider. So you can use Terraform for Google Cloud, you can use it for Azure, you can use it for AWS, and for any other cloud provider out there. But CloudFormation is actually native to AWS, so it's their own, infrastructure as code tool that they developed, primarily for their own services. So CloudFormation only works with AWS. All right. So we're going to be seeing the two, and then we're going to be comparing, what advantage does this have over this one? What's the benefit of using this over this? And then, how do you choose which one to use? So, and then of course, if you're going to be a DevOps engineer as well, you need to understand a bit about Python. Now, knowing Python, of course, in the architecture of today, we're going to be, we're going to be packaging a Python application. All right. So now, knowing Python is not that you want to know it as it's not that you want to know it as somebody who wants to develop a full-fledged application. No, that's not it. But of course, as a DevOps engineer, you must be able to write automation scripts. There are tasks that you want to perform, maybe some repetitive tasks. You need to be able to do some scripting in order to automate, those tasks. And of course, with Python, you can integrate it with Terraform and all this infrastructure as code to automate some things on your infrastructure. And then we're also going to be looking at a few things in Python, and then we're going to be looking at automation with Python, and these are the tasks we're going to be looking at. And then we look at configuration management tool. Like Terraform is an example of a provision, cloud provision management tool, which means you provision infrastructure with Terraform. But then Ansible is a tool that you can use to manage, such infrastructure. So we look at Ansible as well in the course of the training. And last but not the least, for every architecture that you build out on the cloud, monitoring is essential. Monitoring is important. You cannot do without, monitoring. It's very important, because if anything should break, if anything is not going on as you plan, you must be able to identify the cause, where, at what point did this thing happen, and then you begin to trace back and correct what you have to do. So, of course, the live demo we are going to be doing today, the video is going to be available for everybody, whether you are going to decide to join us on the training or not. The video is going to be made available for everybody. And of course, we also have an illustrated handout that we have also done, because we understand that, some people may not be able to sit with a video for such a long time. And so we came up with the idea of having an handout as well, so that if you cannot sit with a video, you can also have an handout that you can also follow through. And then on your own environment as well, you can also build out that architecture following the handout. So we have an handout that we have come up with. Let me just show us that. We're going to be sharing that with everyone on the group. So this is the handout that we have come up with. So this is like a technical guide for the demo that we're going to be doing today. All right. So if you cannot go through, the whole video after the class, or maybe for those who may not be able to join us today, you can also follow this handout. And like I said, it's going to be shared with everybody. The video is going to be shared with everybody. So, but if you do decide to join us, on the program, the next batch is starting by next month, which is May. All right. So if you do decide to join us, you're welcome all the same. And if you are not going to join us, it's okay, it's all good. There's no pressure from anywhere. All right, so basically that's what the training covers, and then we're going to be having the cohort from we're going to be having the onboarding section on the 4th of May, and the training fee is just 2,500, and of course you can pay in installments. We require a $1,000 commitment before the start, and then the remaining 1,500 you can spread it in 3 months. You can pay up that, and I'm sure if you look at the cost that we have here, that's about the cheapest. If you want to do a DevOps training anywhere, I think the list is around 3,500 or 4,000 thereabout. But of course, we have decided to just bring it down to this point. All right, so that's just about the training that we offer. So like I said, if you want to join us, there's no problem. You can reach out to us anytime if you are convinced. And of course, if you are not convinced, it's okay. But of course, the video is going to be shared with everybody, and the handout is going to be made available to everybody. All right, so let's dive in. Let's dive into what we have today. Okay, so let's look at the architecture and let's do a little bit of discussion around the architecture. All right, so now this is what we want to build out. So I'm going to walk us through this architecture real quick. Of course, the architecture is drawn using Draw.io. It's a popular tool for drawing out, cloud architectures and system design and things like that. So if you are not, if you have not used it before, you can try and download it and see if you can also replicate this architecture on your own system as well. So now this architecture that we have here, basically what we are doing is we have this Python application that our developer has given to us. They came to us and they told us, we've just developed this Python application. So as the DevOps engineer, they have handed it over to us so that we can, deploy it into maybe the test environment, because in every environment, in every organization, mostly there are 3 different environments, right? So you have what you call the development environment, you have what you call the testing environment, and then you have what you call the production environment, all right? So our developer, in this case, let's say they have handed over, this Python application to us that, we've just, so the application you requested is available. We've built it out for you. So they've given it to us. Now, the next thing we need to do as a DevOps engineer is that we need to build that application. All right. Now, before you build an application, the first thing that you do is that you test the application, all right, on your system to ensure that everything is running correctly. Now, if everything is running fine on your local host, what you do next is to build it into a Docker image, right? And then once you're done building it out into a Docker image, you push it into what you call an Elastic Container Registry. So basically, an Elastic Container Registry, it's like an image repository. So where you keep a Docker image, all right? So that's the ECR. So if you push it into an ECR, then your Kubernetes cluster and any other kind of Kubernetes cluster that you may have, they can also fetch that image from there and then run that application for you on your own AWS environment or any other cloud environment that you decide to choose. Now, I mentioned something earlier. I said sometimes during an interview, they hand over this architecture to you, that okay, we're listening to what you have to say, we're impressed with your resume, but this is a little challenge that we want to give to you. We give you like a week, go and build out this architecture, and then come back to us and tell us how you built out this architecture. What are the things that you did? Why did you, decide to go this way that you went, and all of that. Now, if you look at this architecture that we have here, we have a VPC section here. Now, for most organizations and for most interviews that you're going to attend, they expect you that this VPC that you have here should be built out using an infrastructure as code tool. Now, the infrastructure as code tool that you decide to use can be Terraform, and it can be AWS. Now, I said Terraform, you can decide to use Terraform because Terraform is cloud agnostic. It works with every cloud provider. And you can also decide to use CloudFormation. But if you're dealing with AWS, it will be understandable if you use CloudFormation, because CloudFormation is native to AWS, right? But of course, in an interview, when you have something like this, the interviewer expects, or the technical director expects, that you build out this architecture, particularly the VPC, using an infrastructure as code tool. Now, if you look within the VPC, you have, you know, your NAT gateway. That's the MGW. You have the NAT gateway, and then if you look at the architecture as well, we have the public subnet, we have the private subnet. So basically, this architecture tells us firsthand that this is an highly available architecture, because we're deploying in 2 availability zones. So which means if one availability zone should go down, then the other availability zone can kick in, where of course that would prevent, you know, any kind of outage that our customers may experience. All right. So now the first thing we're going to do now, right, if you want to build out this architecture, the first thing you need to understand is you need to understand what are the requirements, what is expected of me, what is the first thing that I need to do. All right. Now, the first thing you need to do is to ensure that you have Docker running on your system. All right. Now, what we have done also is that we have also ensured that the illustrated handout that we did a few things. Now, these are the general requirements you need in order to run this application, right? This is the general requirements that you need. Now, you need Microsoft Visual Studio Code to be downloaded on your system. So whether you're using a Mac or a Linux or Windows operating system, you need Microsoft Visual Studio Code. Now, the link is here. So when you get the handout, you can also click on the link and download it on your system. I have downloaded it on my own already, and I'm going to be showing us my Visual Studio Code very soon. Now, the next thing that you need, now, we mentioned that you need to be able to interact with your AWS environment. You need to be able to do a few things. Now, there is what you call access key and secret key on AWS. All right. Now, we're going to be showing us that live. Of course, I have generated mine already, and I will show us how you can also generate yours if you have an AWS account already. Now, the next thing that you also need is to ensure that Python is installed on your system. Because we are building out a Python application and then we're deploying it on AWS. So you need to ensure that you have Python installed on your system. So whether you're using a Mac, Linux, or Windows, you need to ensure that is installed. And of course, the last thing you need to ensure is that you need to ensure that you have Docker installation also on your system. Now, that is the general requirement for everyone. Now, for those who are using Microsoft Windows, now Microsoft Windows has some peculiarities, right? So these are the additional things that you need to also enable if you're using a Windows system. So you need to install this Microsoft CC build. So we provided a link here as well. And then if you're using a Windows also, you must ensure that virtualization is enabled in your BIOS. All right, you can go to your BIOS where you have the system startup of a thing. You can enable your virtualization from there. And then you need to also run your Docker using the Windows subsystem for Linux. For those who are using Windows 11, you need to also run it. And then you open your PowerShell up, and then you run WSL-update, just to update your WSL. And then once you have all of these running, then I think you are good to go. All right, you can start building out this architecture. So let's start off from the AWS environment. Now, the first thing we need to do, like I said, is you need to generate an access key and a secret key. Now, for some of us who may not know what that is just basically saying you need a username and a password for your AWS account. Now, your access key and your secret key, it's what enables you to access AWS, using the command line programmatically. All right, because there are several ways you can access your AWS account. You can access it through the console, and you can also access it through the CLI or programmatic access. Those are the ways by which you can access your AWS environment. All right, so let me log into my AWS environment here so that we can show us. Let me share my screen again. Okay, so logging into my AWS environment. So the first thing we're going to do is to generate our access key and secret key. You need to generate that and have it handy. That's the first thing that you need to do. All right, so it's asking me for an MFA code. An MFA is just a multi-factor authentication. If you want to log in into your Gmail account, for example, for the most part, it's actually going to ask you to authenticate, maybe using your mobile phone or something like that. So it's the same thing that this thing is also asking me to put in a second factor, right? Just to ensure that I am actually the person that is trying to access this environment. All right, so I'm entering now into my AWS account. And if you have any questions, you can just put it in the chat section. We'll try and respond to it as we go on, with the demo. If you have any questions, you can just put it in the chat section. We'll look at it from there and then we'll respond to it. All right, so from here, this is my account. And of course, I mentioned something on the illustrated handout that we're going to be sharing with us, that when you're doing anything on AWS, ensure that you're using an IAM user and not your root account, because best practice is when you create an account on AWS, the first account that you created is actually your root account. So it is expected that after you've created a root account, you're expected to also create an IAM user that you're going to assign maybe an administrator access to, and then you're going to be using the IAM user for whatever operations that you want to perform on the AWS cloud. So it is not advisable that you use your root account. So as you can see here, I'm using an IAM user and not my root account. So best practice in most organizations, of course, you're going to create an account for you, and for each of the accounts, you have policies and permissions attached to them that defines what a user is able to do on the system. All right. Now, I like to explain that using, a house. When it comes to policy. All right. I like to explain that using a house. In a particular house, of course, you may have, a few domestic staff in your house. You may have somebody who watches over your gates. You have somebody who takes care of your kitchen. You have somebody who drives you around with your chauffeur and things like that. Now, every one of these domestic staff, they have their boundaries. They have their limits. All right. So, for example, somebody who watches over the gate is not expected to go into the kitchen and say he wants to cook for you or something. And the person who drives is not expected to be at the gate. All right. So in the AWS environment, there's what you call the principle of least privilege, so which means you only give to users the permissions that they need to do just their job, nothing extra. All right. So that is why it is advised that if you are doing anything on the AWS cloud, you are expected to use an IAM user and not your root account for security reasons. All right. So I'm going to be using an IAM user. Now, if I want to generate, my access key and my secret key, where do I go to? Now, there are two ways. You can click here on IAM, or you can search from this place and just type in IAM. And then if you search from there, it should bring out something. So this is IAM. I can click right here and then it will take me to my IAM account. But of course, that would be like a long journey. So I can actually just click on this point, click on this place, and then go to security credentials, right? So I'll click on that. So that will take me to my security, space where I can now generate my access key and my secret key. Now, like I said, I have generated mine already, because your access key and the secret key is not something that you can display to people publicly, all right, for security reasons. Okay, so AWS, found that generating access key and secret, except you really needed to do something on the AWS cloud. So if you scroll down right here, this is where you have your access key and your secret key. And it is also advised, if you look at this place, I have a key here that is inactive. Now, why is it inactive? Because I'm not using it again. So best practice is, if you are not going to be needing, your access key anytime soon, the best thing is just disable it. All right, just deactivate it. Okay. to avoid anybody, hacking into your system. So I have this one that is active. So we're going to be using this one for our demo today. All right. So if you want to generate your own, it is simple. You can click here on create an access key. Now, I think I have 2 generated already. That's why this place is grayed out. So I can generate, I can't have 3 access keys. You can have more than 2 at a time. So if you click here, you can create your own access key, and then it will walk you through some steps. Let's see if we can actually do this so that I can show us for those who may not know how to do that. So let me just delete this one. I don't really have any need for it again. So let's scroll down again now. So I have the page here. So it's enabled automatically. So you cannot have more than 2 access key in your AWS account. All right. So let's take note of that. So you click here to create an access key. So it will ask you, if you look at what you have, it says AWS key best practice and alternative. It says avoid using long-term credentials like access key to improve your security. So that is why immediately you are done with your access key, the best thing is to deactivate it if you're not going to be using it anytime soon, instead of just leaving it active for so long. And then it tells us here, it says, what do you really need this key for? Is it for CLI access? Is it for local code? Is it for, what is it exactly that you need it for? So if you click on command line, of course, what we want to do is the command line interaction with AWS, right? Because we don't want to come on the AWS cloud and then begin to test out our thing. We want to programmatically, so which means through the CLI, we want to be able to access our AWS account and then provision resources using the AWS account. That's what basically we want to do. So if you click on CLI, of course, it's asking you here to say, you can actually use CLI and use other means, but if you still want to go ahead, it's okay. So you can check here and then you click on next, and then it tells you to give it a tag. And then once you put in your tag and click on create access key, then it creates your access key for you with your secret key. And so once you have that, then you must ensure that you copy that out. So if I click on just put just something here and then create access key. So this is my access key and this is my secret key. So you can actually download this into a CSV file and keep it handy. Now let's pay attention to what we have here. Access key best practices is telling us never store your access key in plain text, disable and delete access key when no longer needed, and then enable least privilege permission. That was what I was talking about earlier, that in AWS, you only give people the permission for what they are, they are meant to do in the AWS environment. You don't give people permission beyond what they are, expected to do within that environment. All right, so that's how you generate it. So you download it, and then I'm going to show us how we can, activate that on our own system right now. So I don't need this access key. So the best thing I can do right now is to do what? Is to just deactivate it right away, since I'm not needed. I'm not going to be using it. So that's deactivated. And then this is the one we're going to be using. So how do you now activate this access key? Now, a few things that you also need to know in addition to what you need to install on your system, there's what you call the AWS CLI, right? The AWS CLI, you need to make sure you have that installed on your system. AWS CLI is important for you to have it installed on your system. So if you type it on Google, you can click on this place, and then it will show you the instructions on how you can install it for Windows, for Linux, for Mac operating system, and whatever operating system that you're using. So you need to have this CLI installed on your system before you can communicate with your AWS account using the command line interface. So these are the instructions. So if you're using Linux, you can expand these and then copy this code to install your AWS CLI. If you're using Mac OS, these are the instructions you need to follow. And then for Windows, you can also follow this instruction to install your AWS CLI. All right. So now let's go onto our own system. Let's see how we can provision this access key and secret key that we just created. How do I enable it? How do I use it to interact with my AWS environment? All right. So let me show us how that is done. All right, so this is my Visual Studio code. This is basically, some of the codes that we're going to be working with. the templates. We have the VPC template IaC here, but of course, we're going to come to all of that. So this is the Visual Studio code that I mentioned that we have to install on our system. So now, if I have this environment right here, let me just clear off this page. All right, so now if I want to access my secret key, if I want to configure it, what do I need to do? What you need to do is just to type in AWS configure. That is assuming you have actually downloaded the AWS CLI and then you have provisioned it as expected. Okay, so you do AWS configure, you press enter. So for me, I have my access key already provisioned, so I don't need to put anything. So for you, you may not have this provision already. So this is where you type in your access key. So you copy it and then you paste it here. And then once you're done, you press next. So it will ask you for your secret key. And then you paste it again. You press next. It will ask you for your default region. So it can be US West, it can be US East. You know, you can get that. I will show us how to get that on our AWS account. You put your region there. Then the next one, you can leave that one as is. And then you press next. And then you have your AWS configured. So once this step has actually been done, now you can interact with your AWS environment. All right. Yes, of course, the template, the Terraform template, the CloudFormation, everything is going to be shared with us. Like I mentioned, I said, even if you decide that you're not going to join us on the training, of course, we're going to be sharing the video, the templates, all the codes that we have here. Everything has actually been pushed into a GitHub repository that we're going to give us access to, so we can go there, download it, use it, and then watch the video as well, and all of that. So all the codes, the videos, every template we're going to be using is going to be shared with everybody. So whether you decide to join the training or not, it's going to be shared with everybody. All right, so that's how you provision your AWS config, right? So with this now, I am able to interact with my AWS, account. So for example, if I do AWS S3 and then I put LS, basically this is saying I'm trying to see S3 basically is just S3 buckets. So I'm trying to list the buckets within my AWS environment. So it's showing me the buckets that I have within my AWS environment. So with this command that I typed in, it clearly shows that now I can programmatically, right, interact with my AWS environment. Okay, so that means we've configured our AWS environment properly, and now we can interact with our AWS environment programmatically. All right, so now the next thing we need to also do from here is to now create our VPC. Now let's go back to the architecture. Let's go back to the architecture. So the first thing we have done now is to ensure that we have programmatic access to our AWS account, right? So we've ensured that we have programmatic access to our AWS account. Now, the next thing we need to do is that we need to provision this VPC that we have here. And in provisioning that, we're going to be doing that also programmatically, right? We are not going to go to the console and start clicking on each of the buttons. Now, what is the advantage of infrastructure as code? Now, let's talk a bit about that. What's the advantage? Why are people saying, you must know infrastructure as code, you must know Terraform, you must know CloudFormation? What is the advantage? Now, if you want to build out the VPC on the AWS console, it's possible, it's easy, right? You just have to do a few clicks and then you have the VPC, set up and all of that. But now the disadvantage of that is this. Now, in a real life environment, you are not going to be deploying applications in just one region, all right? You may have to deploy applications in different regions and different availability zones, all right? So which means, for example, if you deploy your application in US West 2, which is the Oregon region, and then you want to also deploy your VPC in, let's say, maybe the North Virginia region, right? Now, after you have done all the clicking on the AWS console, you go over to the North Virginia region again, you start doing all the clicking. That's a lot of stress, right? Then maybe your organization says, oh, we need to deploy another thing in the EU region, right? Then you go there again, you start doing a lot of clicking. Now, number one, the disadvantage of that is prone to error. You can commit several errors. Number two is if you want to delete some of the things that you have created, you may forget to delete some things. And if you're not careful on AWS, you can incur costs, all right, just by not deleting things properly. Okay. And now that's why organizations are moving towards infrastructure as code. That, okay, you know what, this thing, instead of just going on the console to start clicking here and clicking there, why not, just do this thing on a template, all right? And then with that singular template, we can just launch our infrastructure. And if you feel we don't need this infrastructure again, we can just run just a simple line of command and just delete this whole infrastructure, at once. So that way, if you want to deploy into multi-cloud and into multi-region, it's just a single template. The only thing you need to change is just maybe a few things, within your code, and then you are good to go. You can launch it. In fact, within 30, 40 minutes, you can deploy your VPC infrastructure in maybe like 3-4 regions, all right, within just a few minutes, all right, instead of just clicking around and then making mistakes, forgetting to add something, forgetting to put in something, and all of that. So that's why infrastructure as code is something that, of course, every DevOps engineer, even if you're a cloud engineer, you need to also understand what DevOps, what infrastructure as code is and how you can use it effectively. So we're going to be building out this VPC. So we have a VPC here. We have in the first availability zone, we have a public subnet, and then we also have a private subnet. In the second availability zone, we have a public subnet. We also have a private subnet. All right. So how do you build out this using infrastructure as code? Now, let's go back to our Visual Studio Code and let us see the template that we have already. And let me walk us through the template. Now, right here, I have my template here, which I actually created using infrastructure as code. So I have two different templates here. Okay, this is the Terraform template, and this one is written in CloudFormation. All right, you can write your CloudFormation in YAML, and you can also write your CloudFormation in JSON. But of course, YAML is easier, it's simpler, it's easy to read. So this is the YAML template for VPC architecture. It's about, how many lines of code do I have there? All right, it's about 284 lines, right? It's about 284 lines, okay? All right, okay, so I need to commit it back to Git. That's okay. Now let's walk through this together. In that architecture, let's go back to the architecture. Let's see a few things. So what we need to do basically is that we need to provision a VPC, and then we need 4 subnets, right? We need 4 subnets, 1 VPC and 4 subnets in 2 availability zones. So availability zone 1 is going to have 2 subnets, 1 private, 1 public. Availability zone 2 is going to have 2 subnets, 1 private and 1 public. All right. So that tells us that we need 1 VPC and 4 different subnets. That is what we need to provision. All right, so let's go over to our Visual Studio Code and let us walk through this thing together. Now, if you look at it right here, if you're doing class, of course, this is not a full-fledged, a full-fledged class. Of course, we may not be able to talk us through the whole, code as it is, right? But of course, for those who are going to join us on the training, we're going to walk you through, CloudFormation step by step, Terraform step by step, how you can do all these things, what all these things means. But at a high level, basically, this AWS template version is a default. That's the way you write a CloudFormation template. You need to put in a template version, you put a date. It's actually a default for AWS. That's how they write their own CloudFormation template. And here, I'll put a description here saying parameter to create EKS demo VPC with 2 public subnets and 2 private subnets. And right now, what is parameters? Parameter is just basically, when you think about parameter, think about variables, right? You don't want to add code things. When you're writing a script, you want to give some kind of flexibility to your code, right? And that's why you use parameter. So in Terraform, you call it variables. And that's why if you look at the Terraform I have here, I have what you call a variable.tf file. And then you have your Terraform TF vars file. So your In CloudFormation, we call it parameter. So parameter basically just a way to ensure that your code is flexible. So what I was talking about earlier when I mentioned that I said, if you are to deploy in different regions, right, all you need to do is just to go over to your code and edit a few things. For example, in this my own code here, I have EUS2A. So if I deploy this template in EUS2A, and I also want to deploy the same thing, let's say US is 2 or US was 2, all I need to do is just to come to the parameters here and remove EUS2 and then put EUS was 2 there. And then I go to that region and I deploy it right there. And then I have my resources provisioned for me automatically. That's the advantage of infrastructure as code. So what we have here is just basically, we have defined our availability zones, right? These are the 2 availability zones according to the architecture that we have. These are the 2 availability zones that we have. So we have availability zone 1, which is our EUS-A. We have availability zone 2, which is our EUS2B, right? So these are the 2 availability zones based on our architecture. Now, this other parameter is what is, this is how we are defining our VPC. Now, this is a parameter, all right? It's not the resource. So with this one, it's just, like I said, it's just a way to make sure that your code is flexible, that you can edit your code. And of course, if anybody should have access to this, they can also edit it to suit, whatever it is that they want to do. All right, so our VPC is also created. Now, these are just, all these things that you have here are just restrictions, all right, are just a way to put some kind of restriction to say, this VPC, the CIDR should follow certain pattern, right? If the CIDR does not follow certain pattern, please do not accept whatever value that this person puts in. So when you have a allowed pattern, it's just basically saying, this is the allowed pattern. So this expression that you have here is what you call a regular expression. Now, you don't have to memorize these things. These things are available online. You can copy it and paste it, modify it. The most important thing you need to understand is what it means, how you can use it, right? It doesn't mean that I typed all of these things my own self. I actually just copied it somewhere, put it in there. But of course, you must be able to understand, what you are copying and be able to interpret it and all that. Because if they give you that architecture in an interview and then you come up with this architecture or with this kind of templates, of course, you must be able to talk to your employer through, all of these things, right? So it's okay. You can copy it from anywhere. Most of these things are available online. But the most important thing is that you should be able to understand and explain what each of these things means, right? So you have your allowed patterns, basically just saying your CIDR, which is your IP address, should follow certain pattern. All right. So we have defined a parameter for our VPC right here. And the CIDR that we're using is this. The CIDR is just basically the IP address block that we're using is this one. And then we are saying the type should be a string. That's okay. And then we have a description for it. Now, for the 4 subnet that we want to create, all right, we have all of them, all of them parameterized right here. So after all these parameters has been set, right, now when we go to the console, we're going to see all of these things, how it works. We're going to see them in action. So after the parameter has been set, we now have to define a resource. All right. Now, this is where you now have to define your resources. So this is your EKS demo VPC. The type you want to create is VPC, the CIDR block. So now, if you look at this place now, we are referencing because we have created a parameter for this guy here. So all we need to do here is that we are not going to be coding, all right, the IP address for our VPC here. We're just going to be referencing from this point, all right? Now, the purpose of parameter, again, is just to make sure that your code is flexible. So which means if I need to edit my VPC in the near future, I don't need to come here to come and change anything. All I need to do is to come right here and just edit the value that I have here. That's the only thing that I need to do. All right. And that's the purpose of, parameters. All right. That's the purpose of parameters. So that if you need to change anything, just come here and change it. And then your VPC resource just takes up that value automatically. And that's why you have this reference. So this exclamation ref basically means, you know what? The value for your CIDR block, the value for your IP address, just go and get it from the parameter section. That's where the value is. All right. That's why you have all of this here. And then you have all these ones that are, set to true. Now, what I tell people is this. if you want to understand infrastructure as code, it is easy, but you must understand your way around the console first. That's what I tell people. Infrastructure as code is easy, whether CloudFormation, whether Terraform. It is easy, but if you are not familiar with the console, with the way the console works, infrastructure as code is going to look like magic to you. All right? But if you understand the way the console works, how the console works, you know, whether if I want to create a VPC, for example, on the console, how does it work? How does it happen? What are the things that I need to input? What are the things that I need to check? You know, creating a VPC on the console. If you understand all of those things, then creating the templates, whether CloudFormation or Terraform, is going to be the easiest thing. All right. Now, all these properties that you have here, they are things that you create, you know, when you are creating a VPC. Now, let me just show us a quick example of what I am talking about. Now, let me share my screen. Let me go to the console and let me show us this thing in practical, right? So that it doesn't look. So, for example, this is the console that I'm on the console. So let me go to the VPC. Let's assume I want to create a VPC. All right, I want to create a new VPC in my console. So let's see how that works. Let me go to a region where I don't have any VPC at all created. All right, so let me go to a region where there is no VPC at all. Okay, so let's go to US West Oregon. I actually deleted the default VPC in that region. I deleted it completely for the purpose of this, you know, demo, so that we can understand a few things. All right, now if you look at this place, I don't have any VPC at all. I don't have any VPC created. I don't have anything here. So if I click on your VPC, and then I go to, so you can see there's no VPC here at all, no VPC created. So if I click on create VPC, for example, create VPC. Now, it says to me, the resource to create is what? Is VPC. The name, which is the type, is this. The IPv4 address is this. The tenancy is this one, right? Now, let's assume I create this VPC, let's assume /16. Let's just give it a name. Let's just say EKS demo. Okay. And then let's just create a VPC. Now, the VPC has been created. Now, you see all these things that you have here are referred to as the properties. Okay. The DNS host name is one property. The DNS resolution name is one property. Now, all of these things are things that you also can have on your templates. Okay. So all of these things are the properties. Now, let's go back to the code. Based on what we just saw now, let's go back to the code and let's see. Now, if you look at it, what's the difference between this one and what we just created on the console? There's really no difference, because basically what we're on the console, the only difference is that on the console, you have, you know, you have buttons to click, right? You can click on any button that you want to click. You can click on that. But here, what do I need to do? Resources to create is also what? Is also a VPC. The type is VPC, and these are the properties. So the same property that we also saw on the cloud, or on the console, is also what we have here. So just specifying the CIDR block, enabling DNS, so saying this one to true, the instance tenancy, we saw that, then of course, giving it a name. So I tell people, if you want to understand infrastructure as code, ensure that first of all, you are familiar with the console. If you can get around the console, if you understand how the console works properly, then creating your template, whether with CloudFormation or Terraform, it's an easy thing for you to do. Now, because of our time, I'm just going to run through all of this, and then, of course, you are going to have access to the code, so you can look at it and then try and analyze it in your own way, see how it works, and, you know, if you have any questions, you can also ask, maybe after the class or during the class, you can also ask. So our subnets, of course, we are creating all our subnets from here. The internet gateway, we are specifying that, attached gateway to VPC, all of that. We are creating a NAT gateway, we are creating all of that. So all these things are the things that we're going to be creating on the AWS console. Now, you have written your CloudFormation template. So the next thing we need to do is that we need to provision this, because this is what is going to give us, the architecture that we have been asked to build out. So how do we get this guy into the console? How do we create this? Now, if you look at the Terraform version, this is the Terraform version of the same code. All right, this is the Terraform version of the same code that we have just created. So this is the Terraform example. You can see that one is a bit shorter, just about 151 lines. So this is the Terraform version of it. Like I said, it's been pushed into a Git repo. We're going to share the Git repo with us. You can download it and then also use it. So this is the Terraform version. So you can work with this also if you want. So let's go over to the console. Let's quickly provision this infrastructure. So I'm going to delete this one. We don't need it. So let's delete it. Okay, so that's been deleted. So now let's look at CloudFormation. So here you go to CloudFormation. Once your template is ready, you click on CloudFormation from there. Okay, so I think I created a stack here already. Let me just delete this one. All right, so if I want to create my template, if I want to create my resources, all I need to do is to click on create a new stack, and then I'll click on create a new stack. So to bring me to this point, so what I need to do is to click on upload the template. So my template has been written. I've done all my template. Everything has been written. So choose a file. So from here, I can choose a file that I want, any file of my choosing, and then I can try as much as possible to locate it. So let's try and locate it. Let's locate it. Okay, so it's right here. So yeah, so this is it here. All right. Now, the beautiful thing about CloudFormation is this: the CloudFormation, this template that I've uploaded, I can actually view it in what you call a CloudFormation designer. The benefit of that is that it creates a kind of architecture for you. All right, just like the architecture that we have, CloudFormation can also take your code and then build an architecture for you based on the code or the template that you have provided. So if I want to see how the architecture is going to look like, I can click on View in Designer right here. All right, so click on View in Designer. So that's loading up. All right, so let's see the architecture that we have. I need to scroll down a bit so that I can get the architecture. All right, now can you see? So that's the beauty of CloudFormation. So it can also take your code and build out something like this for you. So that code that we wrote, this is actually the architecture. This is what it's going to look like. So you can see that CloudFormation gives us, that privilege, right? Which of course Terraform does not allow you that opportunity. But with CloudFormation, you can, write your templates, view your template in Designer, and then view what the architecture is going to look like. So for example, in an interview, all right, where they give you a technical task like this, and then you wrote your templates using CloudFormation, you can actually put it in Designer and download. If you click this place, you can download this architecture from here. And then, so when you're presenting your solution to them, you can also show them this architecture to say, I wrote a CloudFormation template, this architecture, this is what it looks like, this is the template and all of that. So just to buttress and just show them that you actually know what you're talking about. So the code, so you can see now the code that we did in CloudFormation is able to transform it into an architecture for us, and then we can actually visually see what it's going to look like. And if you look at it also, all the connections that we made, all right, within that template, you can also see all the arrows. So showing us that this one is related to this one is connected to this resource is connected to this one, you know, and all of those connections, right? So CloudFormation gives us that privilege. So if I want to run this template, all I need to do is to click here on this one, and then it will launch the stack for me right away. Okay, so all I need to do now is to say next, and then I can give it a name. I can call it, I can just say EKS Demo VPC, all right? Now, all the parameters that we specified, you can see that all the parameters are showing up right here, all right? All the parameters are showing up here, okay? All the parameters are coming up here. So I'm actually in another region, Oregon. I'm not in the US East, so I can change it from here. I can change all those parameters right here. That's the benefit of using a parameter, right? Like I said, it makes your code flexible, all right? So I can change all those things from here. And then if I'm okay with all these things, even if I want to change the value of the IP address, I can also change it from here. That's the benefit of using a parameter. Flexibility, you know, is what it offers. So here, now I will say that I want to preserve, I don't want, because what CloudFormation does is this: when you're provisioning the resources, if any of the resources should fail, automatically it will delete all the other resources that provisioned successfully. So we don't want that to be the case. We want to preserve, well, you know, any resources that provision successfully. We want CloudFormation to preserve it for us, and then the ones that do not provision successfully, we just want them to be the way they are. So I'm going to choose the second option. So next. And here I can also go and say submit. Right? So the stack is being created right now. Okay, so if I click on resources, so it's showing me my resources are being created. So you can actually see that, you know, using an infrastructure as code tool is something that is actually very cool, right? You know, the flexibility is there. It gives you a lot of flexibility. It makes your code very clean. You can actually share some of these things with your colleagues, and then they can also version it and see how it all works. So you can see right here, our resources are being created. If you look at events, it shows you the events. So some of the resources have been created completely. Some are still in progress. So if you click on resources again, it shows you the resources that have been created already. Now, if I go from here to the VPC section, I can actually see from the VPC section some of the resources that have been created. So initially in the Oregon region, we don't have any VPC initially, right? But because of the template that we have launched, I'm sure we are going to have a few resources deployed in that region now. So if you look at it now, I have one VPC. You can see I have 4 subnets already. I have 2 NAT gateways provisioned for me, right? So you can see that my infrastructure as code is working. All right, and so these are the things that I have in that template. So everything is working. You can see all the properties that I specified. Everything is enabled. Everything is enabled. Okay, so let's look at our CloudFormation template again. It's still creating some of the resources. Some have been created successfully, and some are still creating, right? So if you look at it again, if I go over here to my subnet, I will see that the first subnet that is needed according to the architecture that we have has also been provisioned, right? And accordingly, their IP addresses have been attached to them. So you have your subnet created. If you look at the route table as well, based on the template that we have, the route table has also been created. All right, so you have your, you know, public route table, you have your routes. So everything that we have on that template is being created right now. You can see how easy that can be. Very easy, very convenient. You don't have to click around and then, you know, waste your time unnecessarily. All right, just a minute. All right, so what I'm going to do is that for the benefit of, you know, for learning purposes, I'm going to, once this one has been created successfully, I'm going to delete it, and then we're going to see how Terraform also does its own creation as well. So I just wanted to show us how the two infrastructure as code tool, how they work. So once the CloudFormation template has completed, deploying all the resources, then I will also show us how you can as well use, sorry, I'm just trying to connect my laptop. So I'm going to show us how you can also use Terraform to deploy the same architecture. All right, so everything is being created. Everything is created successfully. Just a few of this guys is still there. So you can see that all the resources that we needed for our architecture, everything is created, the routes, the NAT gateways and everything is being provisioned at the moment. So everything is good. Okay. So I'm going to show us how we can also deploy the same resources in the same region using Terraform. Okay. I'm going to show us how we can use Terraform to provision the same resources. All right, so let's see, still creating. Okay, so let's leave that. So while that is creating, let me share with us the Terraform side. So I'm going to be doing that on my Linux subsystem, the Linux system that I use. Because as a DevOps person, you need to also use Linux as well. Okay. So let me show us that. All right. So this is the Terraform page. This is the Terraform script that I have created. So it's the same one as the one I showed us. So this one right here is going to provision the same thing, right? We're going to get the same results with this one, right? The CloudFormation template that we just ran earlier will give us the same results as this. Okay. I just decided to do the two so that you can compare and then look at the two codes and see how it works. So if you look at the Terraform template, we have our variables defined here. Now, variables is the same thing as parameter in CloudFormation, right? But in Terraform, they have just decided to call their own variables, okay? So variable is the same thing. Now, this is where you define your variables, your availability zone, your, all the whatever variables that you want to define. And then you use the Terraform TF to assign values to those variables, all right? So there are two things. So you have your variable.tf where you specify the variables that you want to use. And then you use the Terraform.tf to assign values to the variables that you have created. And then you have your main.tf file where you reference all your variables. So for example, this is a variable reference. You can see that I don't have anything coded here. I don't have any value coded in this script. So if I want to change anything, all I need to do is just to go to Terraform.tf, change the value from here. And then if I'm launching my main.tf file, it picks that value by itself automatically from this place, and everything works like that. So if you look at this template that we have here, we really don't have any value, all right, assigned to any resources, all right. Such we don't have any value assigned to any resources because we have parameterized everything. Or in Terraform, you can say you have made sure that you use variables for every of such resources, right? So we're going to be launching the script shortly. And so in Terraform, what you do basically is that, of course, Terraform is cloud agnostic. Unlike CloudFormation, where you go to AWS CloudFormation template and then you launch a template, for Terraform, you do everything, using the command line. So if you have designed or if you have come up with a template like this, the first thing or the most popular command that you type in Terraform is Terraform plan. So you put in your Terraform plan to check. Now, Terraform plan basically is just more like, a way to validate your template, just ensuring that everything that you've written is correct and there are no errors in your template. So you do Terraform plan. The Terraform plan is just basically say, cross-check the code for me. If there are any errors, point it out, and then I will make the necessary corrections, right? So the first thing we want to do here is to do Terraform plan. So Terraform plan. So it will run through the templates and then it will show us some information. So it has successfully run through our template and it's telling us, based on this template that you have given to me, there are 20 resources that will be added, all right, based on this template that you have written right here. So it's telling us there are 20 resources that will be deployed. All right. Now, if you just created a folder for your Terraform in order to do this, the first thing you need to do is to do Terraform init, Terraform initialization, right? And that would give you something like this, and then it will give you something like this as well. Okay. So you do Terraform initialization. So once your initialization is successful, and then you have your script written, then you can go and do your Terraform plan. All right. So this is telling us that there are 20 resources that we deployed in our cloud environment. So basically, let's see. I want to look at the CloudFormation side that we're doing. If that one is done already, if it is not done, we can just delete it off and then use Terraform to now provision the same resources and see how it all works. So let's go over to our CloudFormation guy. Let's see if everything is done. Okay, now the CloudFormation is also done. It's been completed as well. So if you look at it, it's telling us that there are a few errors. Some resources were not able to create successfully. And that was why I chose that option to say, you know what, the ones that create successfully, do not delete them. Just leave out those that didn't create successfully. So it tells us just about 2 items we're not able to create, and it tells us route did not stabilize in expected time. But the funny thing about this error is, if you go over to your cloud, if you go over to your VPC section, you will actually see that this guy was actually created. So the reason why this error came out, well, I really don't know. I've not tried to sit down to figure that out. But of course, if you go over here, you will see that this thing that this guy was saying, is an error, was actually created, because this is the private, subnet, and then it was created successfully. All right. But of course, here it's telling us it's not, it's not been created. And then if you look at the template for the CloudFormation that we had, we also have what you call outputs, right? If you look at it, we have what you call outputs, right? So here we have outputs. Outputs is just basically you need some values, right? You need some values. You've created a NAT gateway. You need the ID of your NAT gateway, or you need the ID of your internet gateway for certain purposes and all of that. So you can also generate an output, and then the CloudFormation will also, get those values for you, and then you can keep it somewhere for your own use later on. So if I go over here to outputs, I will see the values of those things here. Oh, okay, all right. Now it will give me the output because of this error that I have created here. All right, it will not give me the values because it didn't launch successfully, so it won't generate the output for me. But the truth is, all the resources were actually created successfully. All right, so let's delete this, and then so now the beauty of infrastructure as code again is just one click, all the resources will get deleted. All these VPC subnet, routable internet gateway, NAT gateways, everything gets deleted with just one click, which is very easy, because if I want to delete this one on the console, I have to come here, delete all the resources one after another, and that will take a lot of time. But with infrastructure as code, it's just easy, just one click, and then all your infrastructure is deleted. So if I click on delete stack, and then if I go over here to refresh, I will actually see that, after some time, all of these things will get deleted after a few minutes, right? It's still, so you can see it's telling us delete in progress. So if I go to events, it's telling me, some deletion has been completed, and then some are still, deleted. We are still going on with it. If I refresh this page, okay, my VPC is still here. So let's go to route tables. Let's see, do we have it? So you can see route table is no longer there. All the route table have gone. Subnet, do we have any subnets? We have just 2 left, so which means 2 have been deleted automatically. Internet gateway, do we have any internet gateway? That one is still present. Do we have NAT gateways? Is it still there? Can you see? Telling us deleted. So you can see that that is the beauty of infrastructure as code. All right, that's the beauty of infrastructure as code. So everything gets deleted automatically, so you don't have to worry about deleting them manually. So if I refresh again, it's telling me the resources have been deleted completely. If I go to my VPC section, it also tells me that one is still available, so the deletion is still ongoing. So after some time, I will see that All right, the deletion is completed. So it has successfully deleted. Okay, as you can see, I don't have any stack here. So if I refresh this guy again, I shouldn't find any VPC. So you can see my VPC is gone. So with just one click, the magic happens, and then your resources, everything is gone. So you don't have to click and start deleting one after the other, because if you are clicking on the console, you can actually forget, the important things that you actually need to do. All right. And that's the beauty of infrastructure as code. And that's why, companies these days are particular about that skill. All right. So now let's provision the same resources using Terraform, right? So let's go over here. Let's share our screen again. So these are Terraform guide. Terraform script is right here. So we've done Terraform plan. So it's telling us there are 20 resources to add. All right. So let's apply these things. Let's Terraform do its magic for us, and then we'll go over to the console again, and then we'll see that those resources have actually been created. So what you do here is Terraform, apply. And then we don't want Terraform to ask us unnecessary question whether we want to go ahead or not. So what we are just going to do is to say, you know what, just auto approve. And then we click on that. So let's see how Terraform does its own thing aside from CloudFormation. So let's see how Terraform works. Okay, so it's going over our code. So it's telling us there are 20 resources you want to add. So based on the auto approve that we did, of course, the resources have been created right now. So as you can see, the first thing it's doing here is creating a VPC, and then it will create all the resources one after another. So once the VPC has been created successfully, then we will now move on to creating our ECR repository. So you can see Terraform is creating the resources for us automatically. We don't have to do anything. So you can actually see that the only thing you need to just do as a DevOps engineer is just understand how to provision, how to write these templates, and then this creation of resources, you can leave it to Terraform, CloudFormation, and those things. It makes it easier. You don't have to go to the console and start clicking around and all of that. So Terraform is creating our resources for us. Okay, so it's telling us a few resources is still creating. So you can see it's actually very easy. And don't forget, we have done AWS configure. We've created our access key and secret key. So Terraform is able to interact with our environment, our AWS environment. And that's why all this creation is actually going on. All right. So that's just a few minutes, it should be done. And so once that is done, we now move over to creating our Elastic Container Registry. All right, that will store our image for us. Okay, so we're still creating. NAT gateway actually takes a while to create, so it takes a few moments for it to create. So let's just hold on for it a bit. And after some time, okay, still creating. All right, so you can see now that the NAT gateway has been created successfully, and then you have all the other resources specified on the script. You have all of them also being created at the moment. So you can see it's very, it's something that is very easy. Just so, wow, all the 20 resources have been created successfully. So let's verify this on our console. Let's verify. Let us verify. So let me go back to my console here to show us these resources. So if I go over to my VPC again, all right, wow, my VPC is back. Terraform has done the magic. If I go to my subnet, everything is also back. Terraform has done what it knows best how to do. My route table, everything is also back as expected, right? Internet gateway connected as well. My NAT gateway also connected as well. All right, can you see that? My NAT gateway is there. So these are the two that are available. These are the two that was deleted, with the CloudFormation template. So everything is here right now. So you can see, CloudFormation, Terraform, all these tools, they're excellent tools. And of course, there are things that you need to understand as a DevOps engineer. All right, now, the next thing we need to do based on our architecture is to create this ECR repository. All right, we need to create an ECR repository. So how do we create that ECR repository? That is, of course, we also have to programmatically create it. Now, one thing you must understand is that the goal of DevOps is that you want to automate every process as much as possible. All right, that is the goal of DevOps. Okay, the goal of DevOps is not that you should go to the console and be creating things manually. The goal of DevOps, all right, the main purpose of DevOps, or the reason why you're a DevOps engineer, is that you must be able to automate every process as much as possible. All right. So the next thing we want to do now is to create this ECR repository. So we're going to be creating that using what you call an SDK, which is the Python AWS Boto 3, Python SDK. Of course, there are a few requirements that you also need to install. I'm going to show us that right away. All right, so VPC subnet and everything has been created successfully. So we're moving on to the next step. We're moving on to the next step. So let's move on. All right, so let me share my screen here again. And then let's go here. Let's share our screen. Okay, now let me open up my folder. Where are you? Just to read it. Okay, I think this is it. Let me see this one. Sorry. All right. Now, what we want to do now is to create our ECR. Now, this is the ECR repository that we want to create. So now, before you create this ECR repository, there are a few things that you need to install. Now, don't forget, we are trying to package a Python application, and I told us that you need to have Python installed on your system, right? And aside from having Python installed on your system, there are a few Python plugins that you also need to ensure that you have installed on your system. And so this file that you have here, these are the requirements. All right, if you look at this file, this is the requirement. So we need to install all of this Python plugin on our system. All right, you need to install all of this. Now, how do you install these plugins? Now, it's easy. What you need to do is, first of all, when you install Python, your Python application comes with what you call this is a PIP, which is basically a Python package manager, right? So with your PIP, if you want to install any Python package, you install it using PIP. Okay? So if I want to install all these requirements, all I need to do is to do pip 3, and then I do install -r requirements.txt. Okay? Because I don't want to be installing all these things one after the other, right? I need to be able to install all of these things at once. Now, if you look at this requirement file, it's just the name of those applications that you have, or the name of the plugins. Now, the reason why this is because I do not want to, I want to try as much as possible to install the latest version, right? That's the goal. I want to try as much as possible to install the latest version. And that's why I'm just specifying the name of the plugins. So I want Python to help me look for the latest version of these plugins. Okay, I don't want to put any version in front of them, just like what you have here, for example. All right, for example, this one now you have the version that you want and all that. So some of these ones may not be the latest versions, but I want to install the latest version. So what I have here is just their name, and then Python will look it up for me and then install the latest version for me. All right, now if you're using Windows, what you need to type in is pip, just put pip, and then install the same step, -r requirement.txt. the requirement.txt is because it's in the same folder as my current working directory, all right? So I don't need to specify any kind of paths. It's just this particular path that I want. So right here, I'll just press enter, and then the system will walk through for me. You can see it tells me my requirement already satisfied, which means I have this, all this thing installed already. So there's nothing else to install. Okay. So let me clear my screen here. So let's go to our ECR. So the first thing we want to do, we have created our infrastructure, we've created our VPC and our subnets. So the next thing we want to do now is to install or is to provision our Elastic Container Registry. Our Elastic Container Registry, that's what we want to provision. All right. So now this thing that you have here is actually something you can actually get online on the AWS, Boto 3 documentation. You can actually get this there. So let me just quickly show us that. So that we don't look at these things and then we're wondering where is this thing coming from. So go to 3 documentation. So let me show us that here. All right, just a few minutes. Okay. Just a moment. Just a few minutes. Okay. Okay. Let me just quickly show us that documentation. Just a minute, please. Okay, yeah, that's not a problem. I'll do that. I'll paste the command there. That's not an issue. All right. I'll paste it right there. Okay, just a minute. So now this is the documentation, right? This is the Boto 3 documentation. So this is where you can get, if you want to do some, installation on your AWS using Python to, to provision resources on AWS. This is actually the Boto 3 documentation. So if I am looking for ECR, I can search here and type in ECR and press enter. So that would give me, so this is what I'm looking for, ECR. So I'll click on that. So what am I looking for? I want to create an ECR repository, right? So I'll click on this one, create repository. And so this is the command that you have here. So you can copy and paste this command and modify it as you want. And of course, they provide explanations also for you here, as regards, each of these things, what they mean, what they do. So you can read it up and then decide which one you want to use and all of that. So that's where the command is getting from. So somebody was saying I should post the code here. Let me try and get it for you. PIP install -r requirements .txt. Okay. Okay, so we have that. Okay. Just a minute, I'll post the command here. I'm trying to, so that's where you get the thing from. So you can get it from there. And then can you press the last command to install requirements? The command is pip install. All right, then -r, then the name of your file. Okay, So that's the command. So if you're using Windows, you can just use pip. If you're using Linux, you can use pip3, or Mac is also pip3 as well. Okay, so let's create our repository quickly because of time. I think our time is fast spent already. All right, so let's go to our ECR repo. And then from here, so what do we need to do? Now, this is a Python script, right? So that's why you have ECR.py. So now, basically what this is going to do is that it's going to communicate with the ECR. So the ECR is the client, like you can, as you have here. ECR is the client. So the name of the repository is what we have here. We've given it the name. Then these are just like the tags, just to identify the repository. And then we want to do image scanning, right? So anytime you push an image into the repository now, for some of us who may have heard of SonarQube before, SonarQube is actually, a DevOps tool as well that helps you to do code analysis, right? So if you push your code, into Git and then from Git into Jenkins, SonarQube can help you to analyze that code for error. If there are any errors in the code, it will point it out for you so that you can make the corrections before you push, that code into production, right? So your Amazon ECR as well also has that functionality, right? It can also help you to scan, the image that you push into the ECR to check for vulnerabilities and things like that. So here we can also turn it to true to say, you know what, scan any image that we push into this repository, we want you to scan it for us. So that's why we are setting it to true. All right. Now here you have, this command here. Basically, what this one is saying is that when the ECR repository is created, we want to get the ECR URI, right? The URI of the ECR. So we want you to print it out for us so that we can just copy that. So if I don't want to go to the console, I can just use that ECR to connect to my ECR repository. Okay, so that's what this one is doing as well. So what do I need to do? All I need to do is just to do Python 3, and then the name of the file is ecr.py. Okay, and then I press enter, and that should communicate with my AWS environment, and then my ECR repository is created. Now you can see the benefit of infrastructure as code is it makes things a bit easy, right? If you programmatically configure certain things, it's faster compared to creating it manually. So this is the URI of our repository. So how do we verify this? Very easy. We can verify that by simply going to all right, just a minute. Okay, so that can be verified. Okay. So you have your EIR created for you, so you can decide to now go over to the console to check it out. All right. Okay, so let's go to the console. Let's verify what we have just done. Okay, let's verify what we have just done. Okay, let me share my screen again. So if you go over to the console let's search ECR from here. Right, so okay, can you see? So our repository has been created just using the command line. So everything has been created for us. So the scan on push is also been enabled so that anytime we push an image into it, it's going to scan it for us. We're actually going to also see that in action right now. All right, so ECR created. Now the next thing we need to do based on our architecture is to now provision. The next thing we need to do now is to test our application. So the Python app that has been handed over. Now, remember, as a DevOps engineer, you're not a programmer, you're not a software developer. All right, but you're simply working with the developer. So they hand over the code to you. Your role is to package it, know the necessary tools to package it, and make sure that you scan it for any error. And then if there's any error, you report back to the developers to correct whatever error that comes up. So you are not the one that will develop the application. Okay, so the next thing we want to do now is that we want to check this application that our developers done. We want to build it. We want to push it into. We want to package it into a Docker image and all of that good stuff. All right, so let's quickly do that. Okay, so let's test it. So let me stop sharing here. So let's share again from here. Okay, so now this is our app. So basically this application, what this application is doing is just a simple application that connects to your system, and it gets your CPU metric and your memory metric. All right, that's just basically what this application does. All right, and that's why before we could run this application, we had to install all of these requirements. Okay, the Flask, the PSUtil, the plots.ly, and all of that. So we had to install all those requirements in order for us to run this application. So basically, it's just a simple application that connects to your system. It gets the CPU metric, gets your memory metric, and then it displays it in the form of a graph. And you can access it through a web browser. And so we're using a Flask application for that purpose. Like I said, as a DevOps engineer, you are not the one that will build this application. With the developers, they are responsible for this one. But for the purpose of this demo, so that we could understand what we're doing, that's why we are doing this. So now, what we need to do now is that we need to, first of all, before you can package this application into a Docker image, you need to test it locally to be sure that the application is running correctly, and then there are no errors whatsoever. Okay, so how do you run this application? Very simple. The application will be written. So just do app. Just do Python 3, then app.py to run it. So enter. So that will scan through the application. So our application is running on local host. We can access it locally. So if I go over to my browser, let me go over to my browser. I'm going to share my screen shortly. All right, so if you look at this is our application that we have here, right? So it's running. So it's basically getting CPU utilization, and then it's getting my memory utilization. So my system currently, the laptop that I'm using currently, the CPU utilization is around 61.8%. The memory utilization is around 56.6%. So if I refresh it, you will see that the bar will keep moving. It's actually getting it from, it's connecting to my system to get all these details and all of that. So everything is moving. You can see that everything is moving up and down. All right. Now, so we have tested it. We are sure, okay, the application is running and everything is fine. So the next thing we need to do now is to package this application using what you call the Docker file. You use the Docker file to package your application to build an image, right? So let's go back and then let's build our application using the Docker file. Okay, so we can close this. We can clear it off to say, well, we have tested it, everything is fine. All right, so these are Docker files. Basically, the name is just Docker file. It doesn't have any extension, we dot something, it's just Docker file. All right, now this is our Docker file. So the first thing you do is that, okay, you are running a Python application, so you need to get this Python image from Docker up. All right, because of time, we're not able to go through all of that. So you get the image from Docker up, then you create a working directory for your file. Now, the requirement.txt, you must also install it inside of your Docker image. You must package it, alongside the Docker image, right? And then the installation that we also did, you must also ensure that that installation also happens within your Docker image. And then you have to copy the application code. So basically, we are copying this app.py. We are copying it inside of this, the working directory. So we are copying, so the dot means present working directory. And so everything in that working directory, copy it into this app directory. That's what that means. The environment variable, we're exposing our applications to everybody. So basically everybody can access it. And then we're exposing the port 5000. And so when the image has been packaged, and then the moment we run that image, right? The moment you run that image, okay? So I'll be sorry, the moment you run the image, it's going to create a container for you. So once the container is started, then we're giving it an instruction to what? To run our application. That's what we are doing right here. So now, how do you package this? So very simple. What you just do is just to do Docker build -t, Docker build -t, and then you specify where your Docker file is located. So our Docker file is located in this current directory, so we don't have to specify any paths whatsoever. Okay, we don't have to specify any path. So let's press enter. Let's see. I'm trying to look for that. Yeah, so I was wondering that that command was not actually correct. So Docker build. Let me, sorry, just a few minutes. Let me check. Okay. Okay, so let's call this. I think we need to give it a name. Flask app AKS, and then the Docker file. Okay, so Docker build -t, then the name of that image that you're trying to create, and then the dot is actually saying that the Docker file to build this image is in this present working directory. So what this command is basically going to do is that it's going to look out for the Docker file and then build the image. Oh, okay. So I need to run this as sudo. So it's asking for sudo permission. Okay. So sudo. So let's put in the password. All right. So our image is building. So the first thing it's going to do is it will take every of those everything that was specified in that file. It will take it one step, after the other. So it's going to download the Python image from Docker up, and then it's going to copy. So if you look at it, it's running all those things, exporting image, blah blah blah. So it's doing all the necessary stuff. All right, so let's just wait for this to do its thing. It shouldn't take too much of the time because I already created the image before, so it shouldn't take forever. All right, now it didn't take forever because I already have the image created, some time ago as well. So if you want to verify the image that you have created, all you need to do just to do, let me just do sudo su so that I won't be typing sudo every time. So Docker images. So that's how you verify the images. So I have now the image we just created is this one. So we just created this one, Flask app EKS. So if you look at it, it was created 42 seconds ago. And look at the size. That's really massive. 1.12 GB. That's the size of the image. All right. So that's the image we have created. So the next thing we want to do now is that we want to push this image into our ECR that we just created. We want to push it into the ECR that we created. So how do we do that? Now, the good thing about this stuff is that Amazon already, they have all the instruction written out for you on the ECR portal. So if you go to your ECR here, if you click on this ECR, if you click on the repo, so click on that. So you can come here to view push commands, right? So we are going to click on this push commands. Okay. And then we are going to have to copy all of these commands right here. So what I would do is that let me quickly log in into my console on this other system so that it will be easy for me to copy all of these codes. Okay, so let me just go back to my browser here. So let me come here, let me say console. So that it will make it easy for me to access my oops, that's wrong. Okay, class tab, then password. Okay, MFA code. So let's put in our code here. 728-789. Okay. Okay, so that's loading up. Okay, so these are ECR right here. Okay, so here, so view push commands. So we need to copy all these instructions one after the other. So the first one here is just to authenticate with the ECR. All right, that's the first one. So you copy that. And then, so once you copy that, you can go over here. Okay. Just a moment. Just a moment. Okay, so I have to copy those instructions one after the other. So let me see if I can copy all of that instructions. I may have to use. Okay, so let me just use this right here. Okay, all right. Okay, so let's copy this one after the other. So let's copy the first one. And then let's go over to our to this place. So let's clear this. So we paste that here. And then, so that should show us a successful. Okay, so it's telling us it's invalid. Okay, cannot. Okay, so let's check our AWS configure. Let's see if okay. So now the reason why we have that error is because the access key and the secret key that we have here, I'm not sure those details are correct. So let me quickly just confirm that. So it's throwing up an error for us. Now the region is different, the zone is different, the secret key and the access key that we have here is also not corresponding. Okay, so we need to look into that. And then these are the common issues, of course, that you come across in a production environment. So let me find okay. Right. So let me quickly get my key, right? My secret key and my access key. Let me find it so that we can quickly do that. So I will stop sharing now so that I can just quickly provision the AWS configure. Like I said, the secret key and access key is a sensitive thing, so you can't, it's not something you can share publicly. All right, so okay. All right, so okay, so let me just stop sharing and then I'll quickly provision my environment. Okay, so copy and paste it here. Computer. Okay. Access keys. Okay. All right, so let me share my screen again. I've done that right now. Okay, so that is done. So now let's run the command again. Okay, so now it tells us login succeeded, right? So we have successfully authenticated with the AWS ECR. So the second one there is the Docker build. So let me just copy that quickly because of our time. So Docker build. So we're building. Okay, we've built the image already, so we don't need to build anymore. We've done that already. We've built the image already. So the next one there is that we need to tag that image. We need to tag it. So we'll do that by, we need to tag the image. So let's paste that in and then we press enter. So the image has been tagged. So if you want to check if the image has been tagged successfully, you can also run Docker images. So the image has been tagged. So if you look at it here, the image is right here. Where is it? We should do the latest here. We used Flask app ECR record. Latest. So this is the name of the tag. So let's look for that. So 329. Okay. All right. So we have, okay, I think we have multiple, okay, I have multiple images here, so it's difficult trying to find out which one is this. Okay, so the image has been tagged, so let's copy the next one because of time. So the next one is just the command that will do the push. Okay, so here you paste it again. And then, so all the instructions that you have on that page, except for the build one, you will copy them one after the other in order to do your task. All right, so now we want to push it into the ECR repo. So we press enter. All right, so that will also, since we've already authenticated with the ECR repository, so it's pushing right now. All right, so the push operation is ongoing. So that will also take a while. Now, so while the push operation is going on, quickly, let's go over to the console to go and create our Kubernetes cluster, because that also creates time. Your Kubernetes cluster creates, it takes a lot of time. So let's go over to the console. Let's create our Kubernetes cluster while this is pushing here. Okay, so let's go over there and let us go and create our Kubernetes cluster. All right, so right here, I'll go from here and then, so my ECR, the image is coming in there shortly. So let's go and create Elastic Kubernetes cluster. Now, before you create your Kubernetes cluster, there are two things you need to do. You need to create two IAM roles, right, that you're going to attach, one for your cluster and one what the role is. But basically, what a role does for you is that, you know, an AWS service is able to perform operation on another AWS service, right? That's why you need a role. Okay, so let's create, let's go to IAM. So because when it comes to roles, security policies, and all those things, you do them under your IAM. So let's go and create our role under IAM. So we go to IAM, and then we click on roles here. All right, so we click on roles. Okay, so let's create, the first one is your Elastic Kubernetes cluster, roles for your Elastic Kubernetes cluster. So you have to create that one. So you need a role for that. Okay, so right here, you are going to choose under this use case, right? You click on it, and then you scroll down, you look for EKS. EKS. Right here. So this is EKS, Elastic Kubernetes Service. You click on it. So here, all we need is a cluster. So we click on this one. Okay. And then we click on next. Right. So this is the policy. Automatically, policy comes with it. Automatically, policy comes with that role. So this is the policy that you're going to be attaching. So you click on next. So you give it a name. So you can call this my EKS cluster. My EKS cluster role. So once that is done, you can create the role. So that's the first role that you need to create. All right, that's the first role that you need to create. So the second role is for your nodes. Your nodes are basically your EC2 instances that your container would run on. Okay, as your node. So you need to create also a role for your node as well. So let's create that. So create role again. But this time around, since your nodes are EC2, all right, so you're going to be choosing EC2 instead of the EKS that we chose earlier. So EC2, so we click on that. Okay, and then we go next. Okay, so next. Now here you need to attach 3 policies to this. You need to attach 3 policies to this. The question is, how do you get this policy? How do you get this policy? Now, let me just show us. Now, all these things are already on the illustrated handout. It's already there, but let me just see. Okay. So let me show us. That will not look like magic. Again, you can search for these things. You can just search for EKS IAM node rule. All right, so you can just search for it. So there are 3 things you need to attach. This is it right here. The Amazon EKS node IAM rule. So you click on that, and that should so that will take us to the page where we will have to create okay, so these are the 3 policies we need to attach. The Amazon EKS worker node policy, container registry read-only, because our nodes, you're deploying your containers on your nodes, right? Your Kubernetes is managing them. So your nodes needs to be able to access your ECR, right? That's where the image is. And so the image that is running on those nodes is actually in your ECR, right? So your nodes need to be able to access your ECR, and that's why it is just read-only, which means they should be able to pull, the image that you have on your ECR. So you're going to be creating these 3. So let's look for the first one. So the first one is worker node policy, right? So let's search for worker node policy. So let's search for that. Okay, so let me search for them again. Oh, sorry, PS worker. Okay, so this is the policy. So we select that. So that's the first one. So we can cancel this. Now we selected it already. So the second one here is the EC2 container registry. So I can just type EC2 container registry. Okay, so this is what I'm looking for. EC2 container registry read-only. So I'll select that as well. So the last one is something that has to do with networking. So CNI, I can just type in CNI. And that is it right here. So I'll select it. So all the 3 have been selected. So I'll click on next. Okay, so all the 3 policies have been attached to my rule. And then I'll call this rule my EKS node rule, right? And then I can edit this to just say allow EKS to manage EC2 nodes. Okay, and then you click on create role. So that's how you create the role for your Kubernetes cluster. So once, all right, so the 2 roles have been created successfully. So now we can go ahead and create our EKS. Okay, so let's go ahead now and create our Elastic Kubernetes cluster. So you click on Add Cluster, then you click on Create. Okay. So you click on Create. So give it a name. So let's call this. What name can we give this? So let's call this EKS cluster, or let's just say, okay, let's give it Flask app EKS cluster. Okay. So it is best practice that, anytime you're deploying something on the cloud, you try as much as possible to use the latest version, okay, for security reasons, and, so that you can get the best of it. So now the role that we have created already is appearing here because automatically we have created a role. So it's showing up right here. So we can select it. That's the benefit of creating the role, first of all, before coming to create the cluster. So the role is there. So let's tag this. So we give it a name. And then let's just copy this name here and paste it right here as well. So next. Now we need to select the VPC. So this is the reason why we have to deploy the VPC first of all before doing any other thing. So this is the VPC that we have created. So we select it. We're not using all the 4 subnets, right? So we're going to be using the private subnet because we don't want to expose Kubernetes cluster to the public, just like that, all right? Okay, so we want to be able to manage our infrastructure within. Okay, so we're going to be using the private subnet, and that was why we deployed it using an app gateway. If you look at the templates later on, so we're going to be using that. Now, another thing that we forgot to do also is to create a security group. So quickly, let's create a security group, and then we're going to expose, we're able to communicate with our hub locally on the port 5000, right? So we need to also create a security group that will allow that port 5000. So let's go here to create our security group under the VPC section. So let's just quickly do that. Okay, so create security group. So let's call this EKS SG, so EKS security group. So basically we want to allow traffic to our EKS node on port 5000. Okay, that's what we want to do. So let's add an inbound rule. So the port range is 5000. All right, so for now, let's just allow access to from anywhere. Okay, so let's start this as well. So let's tag it. So give it a name. And then we paste it in, and then we create a security group. So if I go back to my Kubernetes cluster and I refresh it, then I should have my security group right here. So this is my security group. So select that and add it. So now this cluster endpoint access, we're going to choose this one, public and private, so that our nodes are actually in the private subnet with the security group and all of that. And then we're going to find a way to expose, the cluster later on, so that we can also allow public access to it. So next. Okay, so it's telling us subnet specified must be in at least 2 different AZs. Wow. Okay. Are they not in different AZs? Oh, okay. Sorry. All right. So 2A and 2B. Sorry, I chose, it was these two that I chose. All right. So 2A and 2B. Okay. So it must be in 2 different availability zones. So 2A, 2B, private, private. So that's fine. Okay. So next. Yep. So we're not doing any monitoring. Next. All of these ones are installed by default. Yes, just go ahead. So what version? So let's try and choose the latest version here. Let's run the latest version for all these things. Next. And then it's telling us, are you okay with all these things? Yes, we're okay. All right. So our Kubernetes cluster is created. Now it takes a little while for your Kubernetes cluster to create. All right, so it's creating. So once this one is done, then we're going to also have to create the node group. That's where you now had your EC2 instances and all of that. Okay, so now let's quickly go back to our ECR. Let's see if our image has been pushed successfully. All right, let's see if our image has been pushed successfully. Okay. Oh, great. So the image has been pushed successfully. Now, while we are waiting for our EKS cluster to be created and to be ready, another thing that we can do as well is also, now the image that we have created, now let's create a container from that image and let's test our Docker image locally, all right, to be sure that all the things that we package is actually correct and then there are no errors whatsoever. Okay, so we have our Docker image has been pushed already to our repository. So if you look at the repository from here, let's look at it. Let's look at the repository. Let's look at the repository. Okay, let's close this. So let's refresh. All right, so our image is here. The image has been pushed. Now, if you look at this image, because we enabled scan on push, if you look at it, it's telling us there are vulnerabilities. So as a DevOps engineer, you are not to sort out the vulnerability because you are not a programmer. So you tell them, oh, the application you gave to me, I did a scan on it before pushing it to production or whatever, and then it brought out all of these vulnerabilities. So the programmers will have to go and look at, the packages and all those things that they have used, make their own corrections, send it back to you again. You push it, you test it, you check it to be sure that there are no vulnerabilities. So look at this. It's telling us that the one is critical. There are 16 of those things that are high. There are 60 of them medium, 40 that are low. 308 of them are just informational, and 143 of them are undefined. So these are the vulnerabilities that has been found in the image that we just pushed. So these are the things that you report back to the developers, and then everybody will look at it together and see what they can also do to rectify these vulnerabilities. So this is an example of what SonarQube also does, just trying to analyze your code and to ensure there are no errors or there are no vulnerabilities. So our image has been successfully pushed into our ECR. And now look at the image. When we packaged it locally, it was about 1-point-something gig. But then when you now pushed it into the repository, the thing was compressed further. And now you just have 374 megabytes. All right. So that's that. So now the next thing we want to do is let's test the Docker image locally, right? Let's test the Docker image locally to be sure that the Docker image is actually okay, everything is fine, and there are no issues. All right, so let's do that. Let's test that locally. So let's go back to our Visual Studio Code environment. Okay, so here, let me just move this up a bit. So let's clear this. So right here, I will do Docker images. Okay, so these are the images that we have here. So the one we pushed, I think the one we pushed is actually the Flask app, right? So the Flask app EKS was the one that we built, right? So let's test it locally to see if it's actually working correctly. So how do you do that? So you just do Docker run. So you want to run the image. So when you run an image, that's when the image becomes a container. All right. But right now it's just an image. But the moment you run that image becomes a container. Okay, so Docker run, and then -d. -d just means we want to run it in a detached mode. We don't want it to give us any kind of logs and all those things. We don't want to litter our screen with different logs and all that. So just run it silently. That's basically what -d is. Then the port, we need to specify the port -p. Port 5000, that's the port number that was specified in the Docker build when we're doing in the Docker file. And then we want to expose the port 5000 also locally too, so that we can communicate with our Docker image or with our container locally in this case. So 5000 as well. So once that is done, then the name of our image. So our image is Flask app-EKS, right? So we specify the tag. The tag is latest. Okay, specify that. That's the tag there. That's latest. So enter. Okay, so your Docker image is running. So how do you verify if your container is up? So you do Docker PS. Okay, Docker PS basically shows you the running containers. So this image is running right now. And so if I should go over to my browser, I should be able to access my application right now. So if I go over here, and then I go to localhost, and I do 5000. All right. So my Docker image is running correctly, and then my application is also visible. So you can see that the Docker image is running, everything is running on fine. So there are no issues whatsoever. Okay, so if you also want to check a few informations about your Docker, you can also do that using what you call Docker logs. So if I want to check a few things about this container that is running, I can do Docker logs, and I will specify the container ID. So I can copy this container ID, copy it, and then come here and paste it. Okay. Okay, so that's the logs right there. Okay, so that's how you check the logs for any container that is running. So for some container that you run, of course, the logs is going to be a bit longer than this one, depending on the application. But of course, since we're just running a simple application, the log is not something that is too heavy. If you're running a Node.js application, for example, the log is usually very long and all that. So this is the log and it's showing us what is going on, when the application started and all. So that is how you run your container. So if you want to stop it, it's simple. You can stop your container by just doing docker stop. Okay, and then you can also paste in the container ID. Okay, enter. So automatically that will stop your container from running. And once the container is stopped from running, of course, you don't have access to that resources again. It's just basically like you're shutting down a system. Okay, so that's just basically what docker stop will do. So now you don't have access to it. So if I do docker PS, I don't have any running containers because I've stopped it. So if I want to check, container that I've run in the past that I have not deleted, it is very easy. All I need to do is just to do docker PS-A, right? So this shows me a list of containers that I've actually run in the past, but of course I have not deleted them for some time. Now, the question is, now I'm doing this so that, let's just give the Kubernetes cluster a few minutes to complete, and then let's just look at a few commands here. So now, if I want to delete any of this container, let's assume, well, I don't need some of these containers here again. So how do I delete these containers, right? So what I can do is I can do docker remove, and then I can copy the container ID and then paste the container ID here. So basically that will remove that container from that place, right? So if you should look at it again, so let's see docker PS-A. So if you look at it, the container we deleted was B654. We can see that we can't find it anymore here, right? We can't find it again. It's been deleted. So that container has been deleted. But when you delete a container, the image that you used to run that container is still available, right? So what you have only deleted is just, maybe the working module of it, right? The image is still available on your system. So if you want to also remove an image, it's also possible. So let's see the images we have. So if I go Docker images, it shows me a list of the images that are available on my system that I've packaged over time. So if I want to delete any of them, all I need to do is to do Docker remove, but in this case, I'm removing images now, not a container. So I'll put Docker RMI. So remove image. So the I signifies an image. So there's a difference between deleting a container and then deleting an image. So if you want to delete an image, you use Docker RM, you put I to signify that you're deleting an image. If you want to delete a container, you do Docker just RM. That's what you need to do. So here I need to also put in the image name. So let's say I want to remove this Postgres here. So if I want to remove this Postgres, I can paste it. Sorry. So let me copy this again. Copy. Paste. So I'm removing this image. I can also associate a tag with it. So Postgres latest. So what is saying? Can you see? Now, what this is saying is because there's a container that is actually using that image. That's why it's bringing out the error. There's a container that is using that image. So it's telling me, if you want to delete this image, then first of all, you must first of all delete the container that is running this image. So you can't just delete an image like that. So before you delete an image, you must ensure that there's no container that is making use of that image. So if we want to do this, we can go back to our Docker PS-A, Docker PS-A to check, okay, wow, we have a lot of containers running this guy. So what we can do is we can force, all right? We can force this thing. So let's do the force option because what we have there is a bit much. So let's do force. Okay, if you look at it, basically it has deleted the image And also the container associated should also be deleted as such. All right, so can we see? It deleted the image, and then of course, all the containers that are running that image were also deleted. Okay, so that's just a few commands that I feel is useful. All right, our Kubernetes cluster is active. Let's go back to it and let's see that in action. Okay, so let's go back to our Kubernetes cluster. So our EKS is up, it's right here. It's everything is good. So what we need to do now is to go to compute section to add our nodes, right? We need to add a node group. So the node group is what will run your Docker image, all right? Kubernetes is just to manage the pods and just administration. That's what your Kubernetes does. So add a node group. So let's call this Flask app group. So the IAM role, we created it earlier, so it should be here. So that's it. So you click on it. We don't have any template. We don't have anything that we're doing here. But we can create a tag as well. So let's create a tag. So from here, let's do next. So let's leave it. We're running Amazon Linux 2. That's okay. Capacity on demand, yes, that's fine. So in order for us not to incur any unnecessary costs, we're going to be using the T2 micro. No. So let's use T2 micro. So it's still under the free tier. So for some of us who have our accounts still under the free tier, we can use the T2 micro. It's free. You will not be charged unnecessarily for it. So using the T2 micro, so this is more like an auto scaling, but Kubernetes is the one doing it for us automatically. So we're saying we want 2 nodes. We want the minimum to be 2, the maximum to be 2. So it's going to create 2 nodes for us in the 2 different availability zone. And then we go next. So the subnet we chose earlier is at the subnet. So next. And then here, we click on create. Okay, so our node is creating. Now, why our node is creating, let's try to authenticate with our Kubernetes cluster. We want to authenticate with our Kubernetes cluster. So let's try and do that. So in order to authenticate with our Kubernetes cluster, we are going to run just one line of command in order to interact with our Kubernetes cluster. Okay, so let me stop sharing from here, and then let's come back to this guy. Okay, so here, let me just clear this off. So in order for us to interact with our Kubernetes cluster, the first thing you want to do is to do kubectl version. Now, the reason why you're doing that is because you want to ensure that you have your Kubernetes installed correctly on your system. So if I type in that, so that gives me some kind of option, and then it tells me that, okay, I have my Kubernetes installation, done correctly. Now, I need to authenticate with my Kubernetes cluster that I've created on AWS Cloud. So how do I do that? So AWS, EKS, so you have updates, and then you have your kube config, then the name of your cluster. Okay, so you put that in. So the name of our own cluster is a Flask app EKS cluster. Okay, so enter. So just the same way we authenticated with our ECR earlier. So this one is also to help us to authenticate with our Kubernetes cluster. So right now we have already successfully authenticated with our Kubernetes cluster. So which means we can begin to deploy our applications on our EKS at the moment. But of course, we have to wait for the node group to create successfully. So here, if I do kubectl version now, I should have a different output. Okay, so now it shows me that it has authenticated successfully. There are no issues whatsoever. Okay, so let's clear off this. So now let's check. Let me just check from my own end here if our node is active now. Okay, the node is still creating. All right. So now let me show us our node is active right now. So we're about, this is about the last step that we have now. So our node here is active. So we can see that our node is active now. So we have two nodes. So we created it. This is just basically an EC2 that he created for us. So he created an EC2 instance for us. One of them, one in each availability zone. If you look at the IP address, you see that they're in different availability zone. All right. And then, so our node is active. So what we need to do now is to push our Kubernetes config, all right, configuration file, the thing that we want to do, the deployment, and then our services, right? And we're also going to be using the Python Boto3 SDK to do that as well. So let's quickly do that. This is just about the last step for this. Okay, so let's quickly do that. All right. So share. Go back here. All right. So now we have our EKS.py here. Our EKS.py right here is here. So if you look at this, our EKS.py is here. Now the Boto3 client that I showed us, you can also get this configuration from there. It's also using the same Boto3 Python SDK. All right. So we're using Python to run our deployment. So this is your deployment. You define your deployment here. You give it a name. And then we need to change this image URI, right? You know, our image is in the ECR repository. So we need to get the current URI and then paste it right here so that our Kubernetes cluster can fetch the correct image from the ECR repository. Okay, so let me just quickly go and grab that. Let me quickly go grab that. Okay, so okay, copied it. So here I need to change this image URI to the current one. All right. So I just paste it here. All right. So that's the okay. Let's retry the sudo. Okay, so that's the current image. So the port that our application is running on is 5,000. And so so there are two steps. You define your deployment. That's the first thing. The second thing is that you create the deployment with just a few lines. Then the third thing is that you define a service. Service is actually something that helps you to expose your Kubernetes, your Kubernetes cluster or your pods. In this case, it helps you to expose your pod maybe to the internet or maybe locally or whichever way you want to access your pod. But in this case, we're using a load balancer, right? So which means we want to be able to access our pod, via the browser, right? Using an AWS load balancer. And of course, in a production environment, that is what you're going to be using. So the type here is a load balancer. The port has been configured. The target port is also being configured right here. So once your service is defined, you also create the service. Now, all of these codes, of course, will be shared with us, but you can also get it on the AWS Boto3 documentation for EKS, right? The place we saw the ECR code, so you can also get it from there. Okay, so what I need to do now is to just do Python 3 and then EKS.py. Oops. Okay, error, no module named Kubernetes. Okay, what could have gone wrong? No module named Kubernetes. Okay, so let's do, what can we do? Okay, let's do kubectl version again. All right, it shows us that it's been authenticated. The next thing we can do now is that the Kubernetes is already here, it's already been installed. But let's run the requirement.txt again. So that means we're going to do Python. Oh, sorry. We're going to do pip3 install -r requirements .txt. Let's run it again and let's see. Oh, wow. Okay. So it seems like it saw something to download. So let's see. Oh, okay. Kubernetes has been downloaded. Oh, wow. I tested this thing already. It's okay. So now, if you run that, requirement.txt, this is exactly what you're going to have, right? So it's good that we are doing this, so at least people can also see this, and so that you're practicing, you know exactly what you have to expect. So this is good. It's good for our learning. So it's installing the Kubernetes for us now. So let's wait for it. I'm surprised that it's doing this. I thought I did this already. It's okay. This is good for our learning so that we can learn and see how all these things work. Okay. So everything has been installed correctly. It's recommended, blah, blah, blah. So we can leave all of that information. So let's run our Pi again. Let's see. So Python 3, EKS of Pi. Okay, so our pod has been created, our deployment has been created. So how do you verify these services? Very simple. Kubectl. So let's do get pods. Okay, get pods. Let's see what we have. Okay, so container creating, can you see? So right now we're interacting with the Kubernetes cluster on AWS, right? We're interacting with the EKS on AWS right now. All right, so it's telling us that the container has been created, so which means our image is fine. It's been able to fetch the image, and right now it's creating a container out of that image. So let's do kubectl get deployment. So let's see the deployment. Now, once you create a deployment, you create your pods automatically. So let's see deployments. Let's see what we have here. All right. So it tells us that our deployment is ready. Everything is fine. So let's look at get pods again. What do we have? So it also tells us that our pod is running, so which means our application is running on Kubernetes, our pods, everything is running, our node is correct. So let's look at services. That's the third thing. So kubectl gets SVC. SVC is basically service. So let's press enter. All right. Now remember, we use an elastic load balancer type, right? So which means we can access our application on, on the browser using the, Amazon Elastic Load Balancer. So it tells us that our Flask service is running using the type load balancer, and then the external IP address for it is actually this guy right here. So if I copy this and I go to my browser, let's go to our browser. What's going on? The thing is not changing. Let's start it again. Okay, just a few moments. We're going to do that now. We're almost wrapping up. Apologies for taking our time. Okay. Okay.
All right.
Okay, so let's go over. We have successfully launched the Kubernetes cluster. So let's see. Okay, now these are Elastic Load Balancer endpoints. But of course, we need to put the 5,000 ports right there. So 5,000 and press enter. So can you see that? So the application is running on Kubernetes right now. So this is the application running on Kubernetes. So if you want to verify this information, right, to be sure that is this thing really running on Kubernetes, or maybe somebody is just trying to place some kind of it's easy. You can go to here, you can come here, and then let's go to our EKS and let's verify some of this information so that it doesn't look like maybe is it actually true or so let's verify this information. So if I go over to my cluster, so this is my Kubernetes cluster. So if I click on my cluster and I go to compute, now if you click on your node group, click on the node group. Okay, now if you go to nodes, it tells you when it was created and all that. So let's click on one of these nodes. Let's click on it. Now, if you look at it, this node is actually the one running our container. Because if you look at it, the available core is just one. All right, system is out. Now, if you look at the ports, we have all our ports running on it. Now, this is, if you look at all the services, you have your AWS node core DNS, Kubernetes and all of that. You have all of this information running on it. So this is the events that has gone on that Kubernetes cluster. So it tells us when the whole thing was starting and all of that information. Let's look at the second port. I want to show us something. Let's look at the second. Let's look at the second one. I think this one. All right. So now this is the one that is actually running our container. How do I know? You can see our service right here. Can you see? This is our service right here. This is the container that we deployed right here. The deployment that we did, that is it right there. So if you look at under the events, it tells us how the whole thing, started and all of that. So it tells you that this is the service that is running, that was deployed. You can see it 6 minutes ago. All right. Now, how do you verify this as well? If I want to verify this locally to be sure that indeed this is my port. Okay. So let's do that. Let's do some verifications so that it doesn't look like maybe somebody's doing some kind of magic. Okay. So let's clear our screen. So let's do kubectl get ports, right? So let's see. Now look at the ports. This is the ID, Flask, 6 whatever. So let me just copy that. Let's just paste that right here for context. All right. So that's the name of our port that is running. So if you look at it, 6 is TD8L6, right? So let's verify and see if it's the same thing that we have in that environment, right? Let's verify if we have the same thing. Do we have the same thing? Can you see that? So that tells you that this particular node, right, this particular EC2 instance is the one that is running, all right, your application, okay? So if you click on it, it can give you further details. So the application is running, okay? This is the name of the container, all right? This is the image, can you see? This is the image that we posted into this thing. This is the port that was opened up. And then this is when the whole thing started. So The container was created, my Flask container created is successfully pulled. Can you see? It successfully pulled the image from the ECR repository, and then the image was pulled and then successfully assigned that image to this pod. Okay, so that is how you verify. All right, so our system is running, and then our Elastic Load Balancer. So you can also verify your Elastic Load Balancer as well. You can also go to your EC2 section and go to Load Balancers. And right there, you will also find the load balancer running. Okay, so this is your load balancer. So this is your load balancer. It's opening up in another place. Can you see? So this is your load balancer. This is the endpoint that we connected to. Can you see? It's running on port 5000. All right, so everything is configured properly. Look at the instances. These are the two instances connected to the load balancer. So everything was done by that deployment and the service that we did. So you don't have to do anything manually, right? So like I said, the goal of DevOps is that you must automate as much as you can. So everything is working. So if you also look at your auto scaling, you also see that you have some auto scaling going on, because don't forget, when we did a cluster, we said we chose 2 by 2, right? 2 nodes and all of that. So you can see. Mr. Bayomi, how do we get the node policy? Can you rephrase the question? Are you talking about the the node role that we created?
Yeah, that's correct. The IAM documentation.
Yeah. Oh, all right. Yeah, it's going to be. We're going to share the what do we call it now? The illustrated handouts. We created an handout for it, so we're going to share it with you. So you're going to find the details on that handout. All right. So you're going to
all right. Thank you.
All right. So this is the auto scaling group that was also created by the Kubernetes cluster. So you can see everything is here. Everything was created by a Kubernetes cluster. This is the instance that we specified, and everything like that. So your auto scaling group was the one that created those 2 instances. And if you also go to your instance, you also find all right, these are the images. These are the instances that you have here. So running, so you can see the IP addresses. You can see these are IP addresses. All right, so there's no fluke or anything there, so you can verify all of those deployments and everything. So the kubectl that we did was just to be able to interact, with the kubectl command. You can interact with your EKS cluster on the AWS cloud. Okay. All right, so that is just what we have for us. Now, the next thing we need to just do now is to terminate, all these things that we have created. All right, so that we don't just accrue any cost unnecessarily. Okay, so we have to terminate all of that. So let's delete our deployment. Let's delete our deployment so that we don't have to. So we just do kubectl delete deployments. So it's going to delete all the deployments that we have. Oh, okay. I need to provide a name for the deployment, right? So let me get the deployment details first. So kubectl gets deployments. So the name of the deployment is my Flask app. So I will do kubectl delete deployment my Flask app. So automatically that will delete your pod automatically. So your pod has been deleted automatically. So if I do kubectl get pods, so you can see it tells me, sorry, kubectl, yes, get pods. So it tells me my pod is what? Can you see that? Because I've deleted the deployment. Automatically, once you delete your deployment, it terminates the pod automatically. So your pod is terminating. So for the service, you also have to do, let's do kubectl get SVC, which is our service. So if I want to delete these as well, I'll do kubectl delete service, and then the name of the service is my Flask service. Okay, so the service has also been deleted. All right, so that is what we have for us. Like I said, if you decide to join our training, it's coming up next month. We have an onboarding section in May, where we're also going to look at a few. We're going to do another demo also by the 4th of May. We're going to have another demo on, setting up Jenkins and stuff like that. So we're going to have another demo on the 4th of May as well, how to set up Jenkins and a few stuff. So if you decide to join the training, you can reach out to us via the Telegram group. You can send a private message if you want to join the training, if you're interested. But of course, the video and the illustrated handouts, like I said, is going to be shared with everybody, regardless whether you join the training or not. Everybody will have access to the video and illustrated handouts. But of course, we wish that people would engage with us, and then we can go through the journey together. So if you have any questions, you are free to ask your questions while I stop the recording so that that one can be processing at the back end. All right.